In this video, I am going to discuss about stretching a function vertically or horizontally. We are going to start off with our favorite function y is equal to x square. It's a parabola going through the origin, meaning the vertex goes through the origin. So we are going to take this function and stretch it vertically. So if I stretch it vertically, this is how it's going to look like. So kind of look skinnier, that's what it is. Let's say I stretch it by a factor of 2. That means it goes up twice as fast compared to the original one. The net effect of this is basically taking the original function x square and multiplying it by 2. That's what it is. Once again, I'm stretching the function by a factor of 2 vertically. So if I were to multiply it by a factor of 3, is going to be stretched 3 times. That means compared to this original function is going to go up 3 times as fast. The net effect visually of this multiplication is basically the function looks thinner. That means you are shrinking it vertically. You are making it skinnier. That's what it is compared to the original function. Original graph y is equal to x square is in blue, and the new stretched, vertically stretched graph is in green. As you can see, it looks skinnier compared to the blue one. That's what the effect is. Now let me give you another example while I'm on this topic. What if I were to multiply this function y is equal to x square by a half? The effect of this thing is that is going to make the original function go up half as fast, like this, half as fast. So this is going to be y is equal to 1/2 times x square, meaning I'm taking the original function x square and I'm multiplying it by 1/2. So if I multiply it by a number between 0 and 1, let's say I'm multiplying it by a constant between 0 and 1, that means it's a fraction, the net effect is going to be stretching the function, stretching the original function horizontally. That means by stretching it to half. That means in reality, if this function is going up by 1 unit at a time, this is going to go up by half as much. Okay. On the other hand, this is going to go up by twice as much because I have multiplied it by 2. So remember, if you are multiplying by a factor between 0 and 1, meaning a fraction, the effect of that multiplication is stretching the original function horizontally, make it look flatter, make it look wider. So you can see this magenta one is looking wider compared to the blue one because I multiplied it by 1/2. If I were to multiply it by 1/4, it's going to look even further wider. That means it flattens the function. And multiplying by an integer greater than 1 or any number greater than 1 basically shrinks it. Okay? So let me summarize what I talked about. My original function is y is equal to x square. I have multiplied it by 2 different numbers. First was y is equal to x square. I multiplied it by 2. The effect of this is shrinking or stretching the function vertically by a factor of 2. Okay. Now the other one was I multiplied it by 1/2. That means I multiplied x squared by 1/2. This flattens the function or stretches the function horizontally. Flattens / stretches the function horizontally by a factor of 1/2. The net effect of this is widening the function. So I could generalize this concept. So if I have a function y is equal to f of x, this is a general function, any function. If I do the following for k between, so k is 1, k between 0 and 1, y is equal to k times f of x is going to flatten horizontally / stretching horizontally. Okay. And case 2, if k is greater than 1, y is equal to k times f of x. It stretches vertically. Stretches vertically. I hope that this discussion was helpful. Thank you very much.